Now let's see how decimal numbers are represented in various representations. So one is I have taken 8421, that is normal BCD, and the other one is XS3 and the other one is 3321. So there are various codes. So first of all, the main challenge here is we have 10 different numbers in decimal, and so we need 10 different combinations of ones and zeros to assign to each one of them. Therefore, how many bits are required so that we can at least get 10 combinations? See this, if I have 1 bit, I get 2 combinations. What are they? 0 and 1. If I have 2 bits, I get 4 combinations. What are they? 0 0 1 0 1 1 and then 0 1, right? 0 0 0 1 1 0 1 1, 4 combinations, right? And similarly, if I have 3 bits, I get 8 combinations. But if I go with only 3 bits, I will not be able to represent every, each one. I will not be able to assign one combination to each decimal digit. Therefore, the only option is I have to go with 4 bits. But the problem is with 4 bits, if I get the combinations, I will be getting 16 combinations. Therefore, with 4 bits, we get 16 combinations, out of which we have to assign 10 combinations to 10 digits, 10 decimal digits in any number representation. Either you go with 8421 or XS3 or 3321. Now, out of these 16 combinations, which 10 are you going to choose and which one are you going to assign to each decimal number? That is the main challenge here. The reason is you have to do it in a meaningful way so that they will be useful for some other purposes. See, representation, yes, it is just giving a combination to something, to some symbol, but then later we should do this assigning in such a meaningful way that later it will be useful for other purposes. I'll tell you what those purposes are. So for now you understand this. With 4 bits, we are going to get 16 combinations, out of which we are going to use only 10 combinations in any representation to represent the 10 digits. Now what happens to the remaining 6? All those 6 are going to be unused, and which 6 are they? That depends on which 10 you have chosen to assign to the numbers, right? Okay, so now let's see what are all the valid codes here. So I have taken this table. See this, I arranged this table in such a way that it will be easy for you to see the table. I just divided these numbers using horizontal lines, and these horizontal lines doesn't have any meaning, only for the convenience of making it clear, and you can easily understand which one is mapped to what. Just for that sense, I have just written it like this. There is no other meaning. Okay, now let's get to the topic. So if you use 8421 representation, which one are you going to give it to the digit is? Straight away we are going to use the formula. So what is the formula? You assign them in such a way that when you multiply that particular digit, particular weight with that bit, whatever you are going to get, that should be equal to the decimal value. So for example, if you see 0 is represented with 0 0 0 0, and 1 is represented with 0 0 0 1, 2 is represented with 0 0 1 0, 3 is 0 0 1 1. So like that you can represent all of them. So it is straightforward. It is simply binary representation only. So 8421 is normal binary numbers, right? Now in this one, what are the 6 combinations that you didn't use? So the next one, the 10, 11, 12, 13, 14, 15, these are the 6 combinations which you didn't use. Therefore, according to 8421 representation, these are all the valid codes, and the remaining 6 are invalid. Now coming to XS3, XS3 is not weighted. That is why I didn't give you any numbers here. I simply told you XS3. Now what does XS3 mean? Whatever number you have taken in 8421, you add 3 to that. Whatever you get, you are going to put it there. For example, 0 is there. To 0 you add 3. Then what do we get? 0 0 1 1. And for 1 you add 3. What do you get? 4. And for 2 you add 3. What do you get? 5. Like that, you take each one of this and you add 3 and you get it. That is XS3. And likewise, 3321 is also a weighted code. So in 3321, one thing you have to observe is, for any number, if you go according to the weights and the formula, you might end up getting more than one combination sometimes. Just observe this. See this? Just pay attention here. It is bit confusing here. So any code like 3321, how do you write it is? So if you have 0 0 0 0, that represents 0 directly, that is fine. If you have to represent 1, there is only one combination, 0 0 0 1. If you have to represent 2, there is only one combination, 0 0 1 0. But if you have to represent 3, we have two combinations or more than two. So if the weight is 3 3 2 1, if I have to represent 3, then what are the combinations I have? 0 0 1 1, 0 1 0 0, 1 0 0 0. So you can represent 3 using these three combinations, but then which one do you want to assign to 3? Because we are not going to assign many combinations to one number. We'll end up with many to one mapping, and then while decoding it is a problem, and moreover the number of patterns or the combinations available will not be sufficient to represent all the numbers. Therefore we are not going to use all these three. You have to choose only one among them. Therefore in any number representation you come across this one, you can use anything, but the convention is this: always go with the smallest binary number possible for the numbers below less than or equal to 4. If the number is less than or equal to 4, always go with the smallest binary number possible. In this, what is this binary number? Normal binary number is 3. In this, what is the normal binary number? 4. In this one, it is 8. 3, 4, 8. Which one should you choose? This 3. That is why 0 0 1 1 is being assigned here. Got it? And then coming to 4, I think there is only one combination, right? So yeah, coming to 4 also you have two combinations. So if you write 4 3 3 2 1, we have two combinations. One is 1 0 0 1 and other is 0 1 0 1. So which one is smaller? In these two, this one is smaller. Therefore you are supposed to use this, right, for 4. Yes. Now once you are done with that, so I hope you understood it. If the number is less than or equal to 4, if it is going to have more than one combination which is suitable to represent a number, go for the smallest number possible. So in this case smallest number is this, and in this case smallest number is this. That is why I assigned there. And second thing is, especially these codes, after till 4 is over, and next thing is, if you want 5, then find out the 1's complement of 9's complement. Okay. So what I mean is, if you want the combination for 5, how to get it is, find out the 9's complement of 5. So what is 9's complement of 5? 9 minus 5 is 4, right? Now you take the combination for 4 and you get the 1's complement. I'll take the combination for 4 and I'll get the 1's complement. 1 0 1 0. Got it? Similarly, take out the 9's complement of, if I want number here, take out the 9's complement of 6. What is it? 3. Right? Find out the 1's complement of 3 and put it there. So what is the 1's complement of 3? 1 1 0 0. Also note that these numbers are again weighted, which means if you convert it using the formula, you will get the actual number. See this: 1 0 1 0. The code is 3321. 3321. And what is 1010? 1010 is 5, isn't it? And what about 1100? 1100 is 6. Now what about 7? 9's complement of 7 is 2. Therefore take 2 and then you find out the 1's complement. So what is it? 1101. So what is 1101? 6 plus 1 is 7. And what about the next one? This one, 8. 9's complement of 8 is 1. Take 1 and then you find out the 1's complement, which is 1110. What about this one? 9. 9's complement of 9 is 0. Therefore you have to take 0 and take the 1's complement. 1 1 1 1. So if you observe this, why is this particular code important? 3321 or whatever codes I told you, why are they important is, they have one interesting property, that is 1's complement of a number is also nothing but the 9's complement of the BCD number. So therefore finding out the 9's complement of BCD is equal to finding the 1's complement of the of that particular number system, right? So if you observe this, what is 9's complement of 0? See this, 9, and what is 1's complement? True, right? So if you take 1's complement, you are going to get this. What is 9's complement of 1? 8. And if you take that 1's complement, you are going to get this. Check these two. Similarly, you can check these two. Similarly, you can check these two, right? That is why this one is self-complementing. This one is self-complementing, right? So 3321 is self-complementing. One interesting property is when the sum of the weights is equal to 9, generally that can be self-complementing. Or if the sum of the weights is not equal to 9, it cannot be self-complementing in case of weighted codes. Therefore 3321 is a weighted code and the sum of the weights is equal to 9, and so it can be self-complementing, and yes, it turned out to be self-complementing. But then I am not saying that every code with 9 as the sum of the weights is self-complementing. For example, if you come up with a code like this 900 and make it self-complementing, I cannot make it. Therefore, if it is possible, it is necessary condition. If a code has to be self-complementing, then the necessary condition is sum of its weights has to be 9. Therefore this one is self-complementing, and also I have given you the representation also and give proof. And now if you observe this XS3, check if it is self-complementing or not. See, and one more thing, the invalid combinations in this 8421 and the invalid combinations in this 3321 or invalid combinations in this XS3 may not be same. For example, 1111 is invalid in 8421 because 1111 represents 15 in this one, and so we are not using it. But then 1111 is used here. Got it? Okay. Now observe this XS3. Is it self-complementing code? So find out what is the representation for 0, 0011, and what is 9's complement of 0, 9. Isn't it? Now find out what is the representation of 9, 1100. If I take the 1's complement, I am getting the 9's complement, isn't it? And you can check for all the numbers. For example, 9's complement of 1 is 8, and if you see them, they are exactly 1's complement of each other, right? And 9's complement of 2 is 7, and if you see them, they are again 1's complement of each other. Likewise, you can see for every number that 9's complement is equal to 1's complement. Therefore this one is also self-complementing. Now just check this one 8421. Right away you can say that it is not self-complementing, because I told you that the necessary condition for any code to be self-complementing is sum of it has to be 9. Okay, do you agree with me, or do you have any doubt there? Why should the self-complementing code should always have the sum of the weights as 9? The reason is simple. See this. Let us say A, B, C, D. If this has to become, okay, I am trying to explain you something which might not be so intuitive. If you understand it, it is okay, otherwise leave it and by heart it. Okay, no, don't by heart it, just see this. Now what I'm trying to say is, if this code ABCD has to be self-complementing, then A plus B plus C plus D should be equal to 9, like this. 3 plus 3 plus 2 plus 1 is equal to 9. This is applicable only for weighted codes. It is not applicable for non-weighted codes, because there are no weights at all. So what do you want to add and compare? Nothing. So it is applicable to weighted codes. In this case it is equal to 9, therefore we are able to make it as self-complementing. Why should this happen is like this. See this? Now let us say I am going to represent some number with 0, 1, 0, 0. Let me call it as x. Some decimal number, I don't know which one. I represented it like this. Now I have to represent, then what should be, if this one has to be self-complementing code, then 9 minus x is the 9's complement of this, should be represented as 1, 0, 1, 1, isn't it? Are you getting this? Therefore, what is this value now? This value is actually B. What is this value now? This value is nothing but A plus C plus D, isn't it? A plus C plus D. Now you add these two, what do we get here? 9. Now you add these two, what do you get here? A plus B plus C plus D, right? Therefore A plus B plus C plus D should be equal to 9 if this ABCD code has to be self-complementing. I hope you are getting this simple logic. A, B, C, D is there, right? Let us assume that I am assigning some number x for this combination 0 1 0 0. What that number could be, since B is 1, the number could be B. Now what about the 9's complement of that? 9 minus x, right? And let's see, if this has to be self-complementing code, then the 1's complement of this pattern 1 0 1 1 has to represent the 9's complement of x, which means 9 minus x. Now what this number can be? This number could be A plus C plus D. Now you add these two, we got 9. You add these two, you got A plus B plus C plus D. Therefore, if a code has to be 9's self-complementing, then the sum of the weights of the code should be equal to 9. And clearly it is not equal to 9 here, therefore it is not self-complementing, right? So what I mean to say is, this one is self-complementing 3 3 2 1, and then this one is self-complementing XS3, but this one is not self-complementing, right? Now let's see this. The next point is, if you observe this 8421 and XS3, they are sequential codes. Sequential means if I take one number and add 1 to that, I get the next one. If I take this one and add 1 to that in binary, I get this one. Add 1, I get this. Add 1, I get this, right? Therefore 8421 is sequential. Sequential is nothing but we are following a sequence. I take a number for 0 and I add 1 to that and I get 1 here, and I add 1 to that and I get 1 here, right? And similarly XS3 is also sequential. You take the starting one, which is 0 0 1 1, and you add a 1 to that, you get the next one. You add a 1 to this, you get the next one. Add 1 to that, you get the next one, right? So that is why it is self-complementing as well as sequential, right? And what about this 3321? It is only self-complementing, it is not sequential, because yes, to some extent you take this one, add 1, you get it. You take this one, add 1, you got it. You take this one, add 1, you got it. But then if you add 1 to that, you didn't get it, isn't it? Therefore it is not sequential. So one thing is 8421 is sequential and 3321 is self-complementing, and XS3 is both self-complementing as well as sequential. So the reason why XS3 is chosen and most frequently used in many systems and not XS4, XS5 is, the reason is simple. It is self-complementing code. If you take XS4 or XS5 or XS6, you will not be getting the same property. So XS3 has got this property that it is self-complementing, and anyway it is sequential because it is derived from the original one. That is why we are going for that, right? So so what you can understand is this one more thing. I have taken only this one, but again I think I have given you many combinations for which the sum of the weights was 9, and I told you that they are all self-complementing. You can take those codes and just derive this. I mean, you just write this how we assign these numbers, and you can see that they are all self-complementing. You do it yourself, okay? So there are some other important representations which we use other than this. And in GATE exam, the most frequently asked questions are about 8421 and XS3 and some other codes like this, and one more is gray code. I'll talk about it, okay?
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.